Have you ever laid back on a cool, clear night and just gazed up at the sky? If you have, you might have noticed something quite peculiar. The stars, those brilliant pinpricks of light scattered across the inky blackness, don't seem to stay in the same place. One night, you might spot a familiar pattern of bright stars right above your house. But a few hours later, or even on the following night, that same pattern seems to have drifted across the sky. It's almost as if the cosmos is putting on a slow, silent show just for you. This celestial dance has puzzled and fascinated humanity for thousands of years, long before we had telescopes or spaceships. This apparent movement isn't just a random shuffle. The stars move in a predictable, organized way. They rise in the east and set in the west, much like the sun and the moon do during the day and night. It's a majestic, silent parade that marches across the heavens. If you were to take a picture of the sky with a camera that has a very long exposure, you wouldn't see dots of light. Instead, you would see beautiful, curved streaks of light, which we call star trails. These trails are the visible proof that the stars are not static points, but are constantly on the move from our perspective here on Earth. But what is causing this grand cosmic motion? Are the stars themselves really zooming across the universe every single night? The answer, as is often the case in science, is both simpler and more profound than you might think. The secret doesn't lie within the stars themselves, which are trillions upon trillions of kilometers away. Instead, the secret lies with the very ground beneath our feet. The Earth, our home planet, is not sitting still. It is in constant motion, and it is this movement that creates the illusion of a dancing, shifting night sky. We are all passengers on a giant spinning spaceship. Understanding this celestial motion begins with understanding our own place in the cosmos. We are not merely observers of the universe, we are active participants within it. Every change we see in the night sky is a direct reflection of our own planet's journey through space. It's a bit like being on a merry-go-round. As you spin, the world outside seems to be whizzing by, even though the trees and buildings are standing perfectly still. The same principle applies to the stars. We are on a spinning planet, and from our point of view, it is the universe that appears to be turning around us. The first and most important movement to understand is the Earth's rotation. Our planet is constantly spinning on its axis, an imaginary line that runs from the North Pole to the South Pole. It completes one full spin approximately every 24 hours. This is what gives us day and night. As the Earth turns, different parts of the planet face the sun, experiencing daylight. The parts that are turned away from the sun are plunged into darkness, revealing the vast star field beyond. This daily spin is the primary reason why the stars appear to march across the sky from east to west throughout the night. Think of the Earth as a spinning top. As it spins, your view of the room changes. If you were sitting on that top, the lamps, the furniture, and the pictures on the wall would all seem to glide past your field of vision. The stars are like the pictures on the wall of the universe. Because we are on the surface of this spinning Earth, our window to the cosmos is constantly changing. The stars we see just after sunset in the eastern sky will have journeyed all the way across to the western horizon by the time the sun rises again. It's a slow, steady waltz, and the Earth is leading the dance. But the Earth's rotation isn't its only move. Our planet is also on a much longer journey. Its orbit around the sun. It takes about 365 days, 1 year, for the Earth to complete one full trip around our star. This annual journey is what causes the seasons. It also has a profound effect on which constellations we can see at night. As the Earth travels along its orbital path, its nighttime side points towards different sections of the universe. This means the backdrop of stars we see changes gradually from one month to the next, revealing a new cosmic vista. Imagine you are walking in a huge circle around a bonfire at night. The bonfire is the sun, and you are the Earth. As you walk, your view of the dark woods surrounding you will change. At one point in your circle, you might see a particular group of tall trees. A few months later, having walked to the other side of the bonfire, those trees will be hidden by the fire's glare, and you will be looking at a completely different part of the forest. This is precisely why we see different constellations during different seasons. The stars of summer are hidden by the sun's glare in winter, and vice versa. While the stars appear to move in unison, you might occasionally spot a few bright points of light that don't seem to follow the rules. These celestial rebels are not stars at all. They are planets in our own solar system. The word planet comes from the ancient Greek word for wanderer, because early astronomers noticed these objects moved differently from the fixed stars. While the stars maintain their positions relative to each other in constellations, planets appear to drift slowly against this stellar background over weeks and months. They are our cosmic neighbors, much closer to us than any star. The reason planets move differently is that they, like Earth, are also orbiting the sun. We are all part of the same cosmic family. Think of it like watching cars on a multi-lane racetrack from the stands. All the cars are going around the track, but some are on inner lanes and move faster, while others are on outer lanes and move more slowly. From your seat, you'll see them overtake each other and change their positions relative to the distant background scenery. Earth and the other planets, like Mars, Jupiter, and Saturn, are like those cars, each in its own orbital lane, moving at its own speed. This difference in orbital speed and path creates the wandering motion we observe. Sometimes a planet might appear to slow down, stop, and even move backward for a short period before resuming its forward motion. This is called retrograde motion, and it's an illusion caused by Earth's own movement. It happens when Earth, on its faster inner orbit, overtakes a slower-moving outer planet like Mars or Jupiter. It's similar to when you are in a car on the motorway and you pass a slower car. For a moment, the other car appears to be moving backward relative to you, even though you are both moving forward. Beyond the steady march of stars and the wandering of planets, other factors can also affect what you see on any given night. The weather, for instance, plays a huge role. Clouds can obscure the entire sky, hiding the cosmic spectacle completely. The phase of the moon also makes a difference. A bright full moon can wash out the light from fainter stars, making them invisible. Furthermore, light pollution from our cities and towns creates a glow in the sky that makes it difficult to see anything but the very brightest stars and planets, which is why the view is always better far away from city lights. The predictable, seasonal change in the visible constellations has been incredibly useful to humans for millennia. Ancient civilizations used the night sky as a giant calendar and a compass. For farmers, the appearance of a certain constellation in the evening sky, like Orion in the winter or Scorpius in the summer, signaled the right time to plant or harvest their crops. For sailors navigating the vast, featureless oceans, the stars provided a reliable map. The North Star, or Polaris for example, appears to stay almost perfectly still in the sky because it is located directly above the Earth's northern axis of rotation. This cosmic calendar is a direct result of Earth's year-long orbit around the Sun. In the northern hemisphere's winter, our nighttime side faces constellations like Orion and Taurus. As we journey through our orbit into spring, our view shifts towards constellations like Leo and Virgo. By the time summer arrives, the nighttime sky is dominated by the constellations of the Summer Triangle, Vega, Deneb, and Altair, as well as Scorpius and Sagittarius, which lie towards the dense center of our Milky Way galaxy. Finally, in autumn, constellations like Pegasus and Andromeda take center stage before Orion rises again to herald the coming of winter. So, the next time you look up at the night sky, remember that you are witnessing more than just a beautiful collection of twinkling lights. You are seeing a dynamic, ever-changing system in motion. You are observing the direct consequences of our planet's spin and its grand voyage around the sun. The stars are not just dancing for your amusement. They are telling you a story about where you are in space and time. They are a reminder that we are part of a vast and interconnected cosmos, a universe that is constantly in motion. I encourage you to become a sky watcher. You don't need a fancy telescope to begin. Just find a dark spot, let your eyes adjust, and notice the patterns. See if you can spot the Big Dipper, or find a bright planet. Then, go out a week later or a month later and see how things have changed. The night sky is a source of endless wonder and discovery. It connects us to our ancestors and to the fundamental truths of the universe. Keep looking up and never stop asking questions. The cosmos is waiting for you.